In a groundbreaking leap for robotics and artificial intelligence, Google Deepmind has unveiled a revolutionary creation, the indestructible AI robot hand. Yes, you heard that right. This isn't just a step forward, it's a giant leap into the future of robotics. Let's dive into the incredible details behind this cutting-edge technology. Deepmind is experimenting with a nearly indestructible robot hand. A new robot hand can withstand being smashed by pistons or walloped with a hammer. It was designed to survive the trial and error interactions required to train AI robots. A new robot hand provides extremely fast and flexible finger movements, while also being tough enough to survive intense damage. That durability helps the hand, which is already being used in Google Deepmind's robotics experiments during the trial and error learning required to train artificial intelligence. The new hand's robust design is well suited for AI-powered robotics experiments based on reinforcement learning, which allows robots to gradually learn how to interact with environments by fumbling through tasks using trial and error, says Ram Ramamurthy at the University of Edinburgh in the UK. Any interaction with the world is a collision damage risk, said Rich Walker, director of the Shadow Robot Company, during a press conference. One trade-off is that the hand is heavier than some other options because the design decisions are aimed at reliability over long-term usage, says Ramamurthy. So why in the world is Deepmind creating an indestructible hand? Google Deepmind is employing a new dexterous and durable three-fingered robotic hand to advance the development of AI in robotics, according to a report. The robot hand in question, developed by UK-based Shadow Robot, is designed to provide comparable force output and movement precision to the human hand. The company, known for its robot hands, claims that its existing Shadow Dexterous Hand series is the most advanced five-fingered robotic hand in the world. It offers advanced accuracy, helping to manipulate tools and objects more precisely than ever. The Shadow Robot website states, "Our technology opens up new avenues for research in robotics and artificial intelligence and enables the refinement of existing technologies." The New Scientist report claims the new three-fingered hand is resistant to repeated abuse, such as being pounded on the fingers by pistons from various directions or being smashed with a hammer by someone. The equipment can transition from fully open to closed in just 500 milliseconds and execute a fingertip pinch with up to 10 newtons of force. The existing Shadow Dexterous Hand series is intended to replicate the kinematics and dexterity of the human hand as nearly as possible. It is sized and shaped like an average male hand. The news suggests that the new hand weighs 4.1 kilograms and 1.2 kilograms per finger. This brings it closer to its Shadow Dexterous Hand and forearm, weighing 4.3 kilograms, which provides a balanced structure for versatile operation. With a robust power grasp capability, the hand can securely handle objects weighing up to 5 kilograms. Engineers claim its movement speed is adaptable and governed by safety parameters within the control system. For full-range joint movements in unrestricted space, the typical frequency is 1 Hz. According to the company, its hand is created using a blend of durable metals and plastics such as aluminum, brass, acetyl, polycarbonate, and polyurethane flesh. The system ensures both strength and flexibility, enabling it to navigate varied tasks with efficiency and precision. The Shadow Dexterous Hand operates as a self-contained system, with all actuation and sensing components integrated into the hand and forearm. Employing Shadow's electric smart motor actuation system, the hand incorporates force and position control electronics, motor drive electronics, motors, gearboxes, force sensing, and communication capabilities into a compact module. Each hand base houses 20 of these modules. Robotics companies may teach Shadow Dexterous Hand to do goal-oriented tasks and control tangible items naturally. Researchers have trained robot hands in simulation using neural networks and the trial and error method, reinforcement learning. The data is then sent to the robot hand, enabling it to carry out the required task in real time and in a real-world environment. Maximizing data acquisition is pivotal, so its hands are equipped with sensors, providing precise data at an advanced rate of up to 1 kHz. According to the firm, with 20 motors, each integrated with temperature, voltage, and current sensors, alongside strain gauges on tendons, meticulous load monitoring is ensured. Additionally, 26 Hall effect sensors meticulously track joint positions with a resolution of 0.2 degrees. The palm boasts an IMU housing, a 3-axis gyroscope and accelerometer for comprehensive motion tracking. Pressure sensor tactile and the fingertips enhance tactile sensitivity, further enriching data collection. Moreover, each hand features 5 analog channels and an auxiliary serial peripheral interface port for customizable sensor integration. According to the firm, operating at 1 kHz, the position control loop ensures rapid and synchronized processing of control variables, facilitating swift and precise manipulation. Shadow Robot claims these comprehensive sensing capabilities empower researchers with a wealth of data, elevating the potential for innovation and advancement in robotics and AI. Alright, here are 7 quick hits about this technology that you need to know. Number 1. Robust construction. The AI robot hand is built from a combination of high-strength alloys and advanced polymers. This unique material blend allows the hand to withstand extreme conditions, including high-impact forces, intense heat, and severe cold. The materials are chosen for their superior resilience and durability, ensuring that the hand remains functional even in the harshest environments. Number 2. Advanced actuators and sensors. This hand is equipped with state-of-the-art actuators and sensors that provide it with a high degree of precision and adaptability. These components enable the hand to perform delicate tasks, such as handling fragile objects, as well as robust operations like lifting heavy weights. The sensor allows the hand to adjust its grip strength and dexterity based on the task at hand. Number 3. Rigorous testing. To ensure its durability, the AI robot hand has undergone extensive testing. It has been subjected to extreme conditions such as being dropped from significant heights, exposed to severe temperature fluctuations, and placed in corrosive environments. These tests have demonstrated the hand's ability to maintain its functionality and performance under stress. Number 4. AI-powered control systems. At the core of the hand's functionality is an advanced AI-powered control system. This system allows the hand to learn from its environment and adapt to different tasks in real time. The AI enables the hand to make intelligent adjustments to its movements and grip based on the specific requirements of each task. Number 5. Practical applications. The indestructible hand has a wide range of potential applications. In industrial settings, it can handle hazardous materials or perform tasks in dangerous environments where human intervention would be risky. Its durability also makes it ideal for space missions, where it can withstand the harsh conditions of outer space. Additionally, it is being considered for use in disaster response scenarios, where its resilience could be crucial for handling emergency situations. Number 6. Collaboration with humans. The design of the AI robot hand includes features that allow it to work collaboratively with human operators. It can perform repetitive or dangerous tasks, thereby enhancing productivity and safety. This collaborative capability is expected to significantly improve efficiency in various work environments. Number 7. Future potential. Google Deepmind's AI robot hand represents a significant step forward in the field of robotics, setting new standards for durability and functionality. Its advanced design and robust construction open up new possibilities for robotics applications, potentially transforming industries and pushing the boundaries of what robots can achieve. The Google Deepmind AI robot hand is a testament to the future of robotics, where machines are not only smarter, but also tougher than ever before. With its indestructible design and advanced AI, it's set to revolutionize industries and redefine what's possible in robotics. Want to see what else is happening in the world of AI robots? Then you definitely need to see this video here.